Anomalous magma blobs hidden under Africa and the Pacific could drown Earth in 100-kilometer layer of lava if they erupt. Despite decades of research, geologists remain divided about many from the processes taking place under the tectonic plates and the Earth's surface. They include details about the churning of molten materials in the Earth's core, and that creates a magnetic field that protects our planet from deadly solar radiation, as we know. Two massive formations of incredibly hot molten rock the size of continents are underneath the Earth's surface. One of them is situated under Africa, and that's where we recently had the Mayotte volcano and the humming heard around the Earth. So that's under Africa. And the other is below the Pacific Ocean. Well, one of the hot spots that we have, and it's very active now, of course, is the hotspot of Hawaii. Now, for the first time, Quanta Magazine created a neat 3D model of formations situated in the area where the Earth's molten iron core meets the rocky lower mantle, showing formations as they appear to leak outwards and upwards towards Earth's crust. And the model shows us an important visual cue which challenges the commonly held view of Earth that one might find in a science textbook that we've been taught so far. It shows geometrically clean spherical orbs of matter. They start with a solid inner core, the outer liquid core, and lower and upper mantle, and finally towards the crust. We see the inner core, which is solid, the outer core liquid, and going out towards the surface we see the stiffer mantle, we see the asthenosphere, and we see the rigid mantle, the ice caps, the crust, the continental crust, granitic, the oceanic crust is basaltic, and we have the continents, the oceans, the hydrosphere, and of course the atmosphere. Earth, and it's drawn from what we see to scale. According to Quanta, the highest points of these formations can reach over 100 times that of Mount Everest. And that's the height of 8,848 meters above sea level. It's the highest mountain on Earth. And if you somehow brought them to the surface, God forbid they contain enough material to cover the entire globe in a lava lake roughly 100 kilometers deep, Quanta contributor Joshua Sokol warns concerning this. This is the diagram showing the two regions of the material sitting, one here that we're looking at under Africa, and opposite that under the Pacific Ocean, modeled by Quanta Magazine. Geologists still do not know exactly what the blobs are and what their role may be in regulating Earth's processes. Well, we know that they could be moving. For example, the top part of this one here in Africa, pointing towards the North Pole, we know that the magma changing its position causes the magnetic North Pole to change and go from movement from Canada towards Siberia. And that's, of course, having to do with the magma that's found underneath the Earth's tectonic plates. Now, since their discovery in the latter part of the 20th century, it's been speculated that they could just be clusters of hot plumes, hence the theory of the convection of superhot rock formations in the mantle, which has been proposed as one of the causes of volcanic hotspots, of course. Other theories say that these blobs are distinct components of Earth's inner geography, that they consist of thermochemical piles of dense rock with a distinct chemical composition of their own, and that they're hotter than the rest of the mantle. The second theory states that these materials are actually as old as Earth itself and unique in their makeup, making it impossible to find them anywhere else on the planet. There's a third theory, and that says that the formations could actually be the remains of a massive ancient planet known as Theia. That's the first I've ever heard of it, but that's the third theory. An massive ancient planet which is speculated crashed into the Earth and became embedded inside our planet after crashing into us some 4.5 billion years ago. It was this event which is believed could have caused the creation of our moon. Our moon was part of Earth, and it was spit out because of this impact, this collision. There are some scientists who support this third theory. Then there are core mysteries. Scientists are not able to reach a consensus on a range of geological processes. They're all theories up to now, and they're taking place below the Earth's crust and has led to concerns about just how much humanity can predict events that can drastically affect our Earth. Last year, the U.S. National Oceanic and Atmospheric Administration, NOAA, and the British Geological Survey were forced to update the world's magnetic model 2 times in 1 year because the magnetic North Pole was shifting from the Canadian Arctic towards Russia's Siberia at a rate of about, accelerated pace of about 34 miles a year. Now, scientists are not, that's a tremendous amount. Scientists are not sure about the precise nature of the process of what's churning the molten metal in Earth's core. And that produces the huge electrical currents to produce the magnetic field of the Earth. At the same time, geologists and scientists express concerns about the possible impact of fluctuations in the magnetic North Pole on the overall strength of our Earth's magnetic field, which protects our planet from harmful solar and cosmic radiation. If the field were to disappear one day, Earth could quickly be bleached dry of life, aka Mars, helpless in the face of powerful solar flares and cosmic rays emitted by our sun and cosmic rays coming into us from the universe. This is on Sputnik News. Now, according to Live Science, Stephanie Pappas writes, strange blobs beneath Earth could be remnants of an ancient magma ocean. The mysterious blobs in Earth's mantle, deep inside, could be minerals that precipitated out of an ancient magma ocean that formed in the collision that also created the moon. This is the third theory of the magma blobs that we were talking about. And they said these blobs, called ultra-low velocity zones, formed very deep in the mantle, close to the Earth's core. They're known only because when seismic waves from earthquakes travel through these blobs, the waves slow dramatically. That means that they show that they're denser. These blobs are dense, and this indicates that the blobs are somehow different from other parts of the mantle, but no one, of course, knows how they're different. New research suggests the blobs could be an iron oxide-rich mineral called magnesio-wustite. If that's so, their existence could hint at a former magma ocean that might have existed 4.5 billion years ago when a huge chunk of space rock rammed into our Earth. This is another planet called Theia, what they've called Theia. This is the third hypothesis. So the space rock slammed into our Earth, spitting out part of our Earth, causing the formation of the moon. It rammed into our Earth, spun off the material that would become the moon, and possibly melted large portions of our planet. So if one can identify that these patches do contain an amount of magnesio-wustite, that would be an indication that there was a magma ocean, and it crystallized in this fashion where the iron-rich oxide precipitated out and sank down to the base of this mantle. This is what the leader of the study, Jennifer Jackson, professor of mineral physics at California Institute of Technology, states. These are odd blobs. The mantle is around 1,800 miles thick. With the ultra-low velocity zones, they're less than a mile, up to 62 miles thick and wide. They slow down seismic waves that travel through them from 30 to 50%. And the study showed that these weird blobs studying them is not possible directly. So Jackson and her colleagues had to mimic pressures of the deep mantle right at Earth's surface to find out if the mineral magnesio-wustite has the kind of properties seen in ultra-low velocity zones. They took small samples of the mineral, put it in a pressure chamber, squeezed it hard with a pair of diamond anvils, and the whole pressurized apparatus is small enough to fit into the palm of a hand. Jackson said, "Sometimes I'll say that I'm carrying around the core mantle boundary pressure in my pocket." But anyway, the researchers bombarded this sample with X-rays from different angles. Then they measured the energy of the X-rays as they exited the sample, looking for how interactions with the crystalline structure of the mineral changed them. And under pressure, they found that this high pressure changed everything. At atmospheric pressure, Jackson said waves existing at magnesiowustite are always the same, no matter what direction they travel through the crystal. At core mantle boundary pressures, though, the direction the waves travel matters it matters a lot. There can be up to 60% difference in the speed of the wave going through the crystal, depending on how it passes through. A transverse wave traveling through the mineral moves a little less than 1.8 miles per second in one direction and a little more than 3.1 miles per second in another. The fastest direction of travel for these waves at atmospheric pressure along the edge of the crystal structure is the slowest direction of travel for waves at core mantle pressure, she said. The fastest direction of travel at core mantle pressure is across the face of the crystal in the lab, and these differences in how waves travel, depending on the direction of the crystalline structure, are called anisotropies. And what does that mean for the real mantle? Well, anisotropies have been observed down there too, she says. No one has really looked to see if ultra-low velocity zones have them, but there's reason to think they might. If the cooling magma ocean theory is true, and there is magnesiowustite deep in the mantle, it could be pushed, squished, and nudged into an anisotropic configuration by pieces of oceanic crust that have been pushed deep into the mantle in the process of subduction. Subduction zones. This is when one piece of crust pushes below another and dives into the mantle, as happens in the coast of northwestern North America. If we can look for it, it would be really good evidence to suggest that this interaction of ancient slab subduction and ultra-low velocity zones that contains this iron-rich oxide. Now Jackson hopes that the seismologist could see the seismic waves that enter ultra-low velocity zones come out differently depending on the direction of travel. And if they do, it will bolster the magnesiowustite hypothesis. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.